This is the methyl salicylate experiment. Okay. And to start out with, you'll see when I add methyl salicylate, you should see the drops fall to the bottom of the container. Okay. So we have 5 drops, and again it's collected there in the bottom because methyl salicylate is non-polar. And alright, so we'll just sit down in their bottom and not mix with the water. You can see it's falling down as I shake it. Okay, so again, just 5 drops of methyl salicylate. It has a wintergreen smell to it. Okay, so methyl salicylate is a wintergreen odor. Here is the test tube after the reaction of the sodium hydroxide. So it saponified the methyl salicylate, okay, and we've created methanol and the salicylate ion, or you could say sodium salicylate because it matched up with the sodium from the sodium hydroxide. So again, there's no longer 2 layers. Okay, so the salicylate ion is soluble. When I add hydrochloric acid, we're going to protonate that salicylate ion, okay, and make it into salicylic acid, and that's going to be non-soluble. So again, as we add hydrochloric acid, we're going to start neutralizing the solution, and then we're going to start seeing some precipitate form. Okay, so you can see some white cloudiness to the solution. Okay, that's the salicylic acid that's forming as we protonate the salicylate ion. Okay, so you can see a solid forming because the salicylic acid is not as soluble as the salicylate ion because it no longer has a negative charge. If we add sodium hydroxide back to the solution, we'll start taking that proton away from the salicylic acid, and it's going to be soluble again. Okay, so as I shake that up, you should see more of that dissolve. And if we keep adding a little bit more, we should be able to make that solution go completely clear because the salicylate ion is fairly soluble. Just a little bit of it left.